2. As I was watching that, I thought of two things I wanted to mention. Thing number one is right here. Let's continue this pattern backwards. 5, 4, 3, 2, 1, 0. This is 1 times 2 to the 0. You see it? I know, because the first time you see the 0 exponent rule, you're like, oh, it's just magic. Now you're kind of seeing, oh yeah, that does work like that. So of course, 2 to the 0 is 1. 1 times 1 is 1. The other thing I wanted to mention was I said, that the larger the growth factor, the bigger your B is, the more steep it is. That's true when your scales are the same. However, for example, you could change this scale right here to be like a billion right there, right? You could put a billion here and decide, I'm going to count by a billion. And then your graph would look like this. It wouldn't look very steep because of the scale. So yes, if your scales are the same, the larger your B, the more steep it is. But don't just necessarily judge how big B must be by the scale, because sometimes, if I made a scale that's really weird, I can make something that grows tremendously look pretty flat, or vice versa. All right, let's go to the next example. Okay, let's do one about decay. Sierra. Yeah, that's you, Sierra. Sierra P, the one who always watches this video first. You're always the first person to watch the video, so I'm dedicating this example to you. Sierra has a brand new Mercedes-Benz. Congratulations. That costs 50 grand. Every year it loses 20% of its value. Kind of congratulations then. What will it be worth in 10 years? Okay. So here we go. Over here we have the value, which we will call X. Here we have the years, which we will call X. And over here we have the value, which we will call f of x. In other words, the value is a function of the time. That's why it's f of x. Okay, so we know that at year 0 right now, it's worth 50,000 bucks. All righty, that's not bad at all. And it's losing 20% of its value every year. All right, I got to find 20%. And what would be worth in 10 years? 20%. How am I going to find 20%? Well, there's several ways you can do it. I'm going to do the first one mentally. I know that 10% is 5,000. So 10% of 50,000, oops, too many zeros, is 5,000. So if 10% is 5,000, then 20% must be 10,000, twice as much. So after 1 year, it's going to go down by 10,000 bucks. All right. The next year, well, what's 10% of 40,000? Well, 10% of 40,000 is 4,000. So if 10% is 4,000, 20% is double that. So 8,000. So it's going to lose $8,000. All right. I can do another one in my head. What's 10% of 32,000? Well, that'd be 3,200. If 10% is 3,200, 20% is twice that, or 6,400. So if I subtract 6,400, I'm at this. All righty. Now I got to find 20% of that and subtract it. Now, if these numbers get too hard, what I would just do is I would do this. I'd go to Google and I'd say, all right, calculator. I get myself a calculator and I say, all right, what's 20%? So 20% is 0.20, and then times 25,600, and it's that much. So 5,120. So it's going to go down by 5,120. So then I will do this minus 5,120, and I got my new value of 20,480. And so that's going to be the next one. So we could keep doing this. However, we could ask ourselves, well, wait a minute. I know that I'm multiplying by something here, and I just need to figure out what I'm multiplying by. Now, some of you might be thinking, I know it. And others of you might be like, I have no clue. So here's what we can do. If I don't know what 50,000 times what gives me 40,000, I'm going to do it backwards and divide and see. So let's go backwards. Let's do 40,000 divided by 50,000. So let's go back to this calculator I had. And I'm going to do 40,000 divided by 50,000. Oops, too many. How do I go back just one of them? Maybe delete it. Yes, very good. 0.8. So that means that 50,000 times 0.8 must equal 40,000. See, 50,000 times 0.8 is going to give you 40,000. Times 0.8 is going to give me 32,000. Times 0.8 is going to give me the next number, and all the way down. So I'm multiplying times 0.8. So times 0.8 times 0.8 times 0.8 And therefore, if I want to then find the 10th year, I realize that I started at 50,000 and I multiplied times 0.8 times 0.8 times 0.8 times 0.8 10 times. And therefore, that's going to be my answer. So I'm going to go ahead and take my calculator and get a final answer for that. And the answer is that in 10 years, this poor car is only going to be worth $5,368.71, which is why if you go online and try to buy a car that's 10 years old, even if it's like fancy, like, ooh, a Mercedes-Benz, it'll be like $5,000, you can have it, because cars lose their value pretty rapidly. Okay, now, where in the world did I get that 0.8 besides the calculator? Some of you guys figured it out already. I know you did. Because I said that the general form is a times b to the x, and b, unless it's obvious, like doubling or tripling or halving, is very often 1 plus or minus the percentage to the x. And in this particular case, my a is 50,000. That's your initial amount. 1 is just 1. Minus, because it's decaying, r is your percent as a decimal, which is going to be 0.20 to the x. So if I were to combine this together now, 50,000, what is 1 minus 0.2? 0.8. And therefore your equation is y equals 50,000 times 0.8 to the x. Cool, huh? The graph is going to look something like this. What am I going to count by? I changed my mind. I'm going to count by 10,000s, by 5,000s actually. So here's 10K, here's 20K, here's 30K. K stands for 1,000. Stands for kilo, which is Latin for 1,000. Okay, so I start off at 50,000. After 1 year, it's already down at 40. Then at 32. Then at 25 after 3 years. It's at 20 after 4 years. You see how that's starting to bend? And I skipped a whole bunch of years because I didn't feel like doing all that. And then it comes down to here. So my curve is going to look like this. And if you guys would like to put more years in there, you can. One word of caution, make sure that your line, your curve, never goes below the x-axis, because that would mean the car is worth negative, and it can't be worth negative. Because even if you take away 20% of something that you take away, you're always going to have something left. It's never going to be like negative. Even if it's only worth $1, it's going to be worth 80 cents and then 64 cents. It's never going to get to zero, technically. Okay, some formulas that I wanted to give you, I have given to you. Here they are. It is these guys. These are the formulas that you need for exponential growth or decay. And remember, this R is your percent as a decimal. And your teacher back in 6th grade taught you to find write a percent as decimal, just move the decimal point back 2 places. So for example, if something's growing by 5%, that would be 0.05. You got to move it back 2 places. You remember that? Good. Okay. One little item of curiosity. This is kind of interesting. So I said that the formula should be this, right? What about in this first case if you're just doubling? There's a 2 there. Does this formula apply there? The answer is yes, it does. That first example is simply f of x equals 1, the original cookie, times 1 plus 1 to the x. That's how I get 2. Well, that percent is actually 100%. So in other words, John is bringing 100% more cookies each day. So yeah, even in this first one, this formula does apply. This formula always works, even if something's doubling or tripling. Tripling just means growing by 200%. Quadrupling means growing by 300%, and so on. Okay, we are going to do one more video this week in which we're going to do some rapid fire questions. Have a calculator handy because you're going to be doing some questions quickly. We're going to get good at this. And this is also what we're going to be doing at some of the meets this week. So show up to the meets and we'll practice more. Okay, see you next video.